So I'll start by saying that this spreadsheet is pointless for more than one reason. The first being that you can generate barcodes online for free, and there are also existing applications for this already. And secondly, there's already a built-in way to do this even within a spreadsheet, which is just with barcode font. But I have a project in the back of my head that I've been working on a little bit, and it involves barcode. And so I thought this would be a good opportunity to learn a little bit more about barcode. And also I just thought it'd be fun to give it a try. So what I wanted to do was create rows that were 1 pixel high, or 1 point whatever unit of measure Excel uses for row height. I wanted to create rows that were 1 unit high and format them to be black or white based on the outcome of a formula. And then I would do that for however many rows I needed to create a barcode. So I decided to model this off of code 39 barcode, which I determined to be 15 bits per character, plus the separating character that goes at the, or separating bit that goes at the end, an off bit. So 16 bits per character, and I wanted to make a 16 character long barcode, and then there's a start and stop character of an asterisk, so I needed 18 characters at 16 bits each, which was 288 rows. So I formatted 288 rows to be 1 point high, and the cells are also formatted to fill in black if the value of the cell is 1, and fill in white if the value of the cell is 0, plus also white out the text. The next decision was to create a table or matrix, I call it a matrix in this case, of rows and columns where the top of each row is the character that's going to be represented by the barcode, and then the rows below in that column, the rows below are the separated out, parsed out, are the binary values of the on-off bits for that barcode character. I separated them out because it seemed like an unnecessary extra step to type them and then use mid or left or right something to separate them back out into cells. It really wasn't any harder to type them, and honestly it makes it easier to edit later on with them typed out. And they're vertical so that you'll see later on it makes it easier to work the formula into the actual section of the spreadsheet that generates the barcode. And this formula right here is basically what makes everything work. It starts out by looking for a blank space in the input cell that you're typing into, because I use an HLOOKUP to find the character that you're typing in the matrix of the binary for each character, and Excel doesn't recognize spaces for HLOOKUP. I could have used an underscore here, but I wanted the interface of the input of the information to be as smooth as possible. So I used an underscore as a placeholder in the matrix, but I used an if statement to evaluate the cell first, and if it's blank, it does an HLOOKUP for the underscore and returns the bits for a space character. If it's not blank, then it moves on with an HLOOKUP for whatever for your target cell, whatever you're typing in there. The matrix of the character binary bits at the top of each column, I have the character itself, so the HLOOKUP just looks at the cell that you're typing in, and then the row position from the HLOOKUP is a variable, and that's driven by just a random column of numbers that exists, or not a random column of numbers, a column of numbers that exists randomly on the spreadsheet that goes through from 2 to 17. You'll notice in the whole formula, everything is an absolute position, except for one cell that appears 2 places. And I have that non-absolute so that I could type this code, this formula, and drag it, and the row position for the HLOOKUP would shift however many times you drag it, because it's when you shift it, that non-absolute cell looks at the next cell down in that column of numbers 2 through 17. So I get the second row from the matrix of binary bits down to the 17th row, which is the 16th bit. Basically, I wanted all of this to work with the minimal amount of typing. in typing in terms of making adjustments later on. So I had to do a lot of typing at first, especially with typing in the binary code. But this formula I really only had to work up one time, and then I was just able to copy and paste it 16 times, change a few column values, and then drag it 16 times, and it populated all the information itself. And so if I had to go back and change this to say I was going to change it to 12 bits instead of 16, which I might have to, and I'll get to that, I could just change my table matrix by deleting rows, and the formula will update automatically. And then I just select the rows in the barcode section that I want, delete those, all the formulas will keep themselves up to date. So I can change everything pretty easily because of the way this formula is laid out. So you can start to see the barcode coming together towards the end of the video here. And the last few things that I do are just sort of formatting for the input. I lock the cells, I make it so that you can only type one character per cell in the input, and because I lock everything except for those 16 cells, when you hit enter it automatically moves to the next cell. When you get to the end, it goes back to the beginning. Do a little making it look a little nicer with colors. I also use a concatenate to grab all 16 characters from the input cells, put them into one cell that is merged and centered, and then formatted to turn it 90 degrees, because that's how a code 39 barcode appears. It has the human readable text laid out next to the barcode, and then I just use an upper call out for upper function for translating it all to uppercase, because technically it's all supposed to be uppercase. In a barcode reader, we'll read it as uppercase. You'll see throughout the video that I Google a ton of this stuff, which is how I do absolutely everything. When I got to the end and I wanted the text to be turned 90 degrees and by the barcode, and I wanted it to be uppercase, but I didn't want the user to have to input it in uppercase. I knew that there'd have to be a way to do that. So I just Google Excel make uppercase and just found the equals upper. And so you'll see a lot of that going on in the background of the video.
I mentioned earlier about the possibility of having to change the number of bits that I use for each character, and I did actually end up having to do that. Basically, the way a barcode works is that the lines are not strictly an on or an off. It's on or off, and also wide or narrow. It uses this method of coding called 2 of 5, which is like a mathematical way of deriving something about the lines and it representing some total number of combinations. I don't fully understand it. But the standard for code 39 is that the wide bars are to be 2 to 3 times wider than the narrow bars. And when I laid all this out, I found that to be, I would need 15 bits for each character, plus my 16th bit, which is the off bit that goes in between each character. This allowed me to use 3 bits for the wide lines and 1 bit for the narrow lines. It ended up not really scanning all that well. It would probably only work 20 to 30% of the time. I think it had something to do with just the resolution of the way the lines worked and how it was printed. So I went back and changed it to be the wide lines being twice as wide as the narrow lines, so it used 2 bits for the wide and 1 bit for the narrow. And so I just had to modify the matrix to get rid of the unnecessary bits. And this was another thing I Googled, because I deleted the unnecessary bits and then I was shifting them up manually so I didn't have to retype it all. And I thought there's got to be a better way to do this, and there's a built-in function in Excel for highlighting data and then eliminating empty cells and shifting the data up. So here is the finished product.